Hi, this is Mr. Budehas. Welcome to my channel. This is my first ever video in YouTube, and to be honest, I am not that confident in making this video because I know I don't have a good voice like others. But due to COVID-19, since all face-to-face classes were suspended, I decided to make a video about the remaining topics in mathematics on their fourth quarter so that my students can still learn the things that they need to learn in this level while staying at home. The content of this channel is all about mathematics, and I am using the PowerPoint presentation given to us by the Quipper. So if you are interested in my next videos, please subscribe to this channel. In this video, I'm gonna show you how fundamental counting principle works and how to solve factorials. First, fundamental counting principle. It is a mathematical way used to find the number of possible outcomes of an experiment. In a compound event in which the first event may occur in n sub 1 different ways, the second event may occur in n sub 2 different ways, and so on, and the kth event may occur in n sub k different ways. Now, the total number of ways the compound event may occur is just multiply all the different ways. We have n sub 1 times n sub 2 times n sub 3 up to n sub k. That's how fundamental counting principle works. For example, a food stall sells squid ball, fish ball, and kikiam. And there are also three choices for the sauce: sweet, spicy, or sweet and spicy. How many different combinations are possible? To answer this problem, we have to identify how many events do we have in our example. Here, we only have two events, the food choice and the sauce. For the food choice, we have SB represents squid ball, FB represent fish ball, K for kikiam, and for the sauces here, the blue color, SW for sweet, SP for spicy, SW and SP for sweet and spicy. Now, after we identify the two events here, we are now ready for the listing of all combinations here. We will start from the squid ball. Squid ball with the different sauces. Squid ball with sweet sauce, squid ball with spicy sauce, squid ball with sweet and spicy. And the same thing here with the fish ball and the kikiam. Now, after we list all the combinations, we are now to count all of these combinations. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, there are 9 different combinations. If we are to apply the idea of fundamental counting principle here, just multiply the number of different ways in each event. In our event A, we have 3 different choices, and for event B, we have 3 different choices. So multiply them, we get 9. And that's how fundamental counting principle works. Another way of solving this problem is by using tree diagram. At first, there are 3 main branches, the red color, which represents event A, or the food choices, the squid ball, fish ball, and the kikiam. In each branch, there are 3 more branches, the blue color, and that represents event B, or the sauces, sweet, spicy, or sweet and spicy. Each branch in event A has the same selection of sauces in event B. Since there are only 2 event or actions for you to order a food in a food stall, you can now start combining the food and the sauce, or just add event A and event B. The area right here is the combination of squid ball and sweet sauce. Next is the squid ball and spicy sauce. Then, squid ball with sweet and spicy. Keep on doing this process all the way down to the bottom. Then count all the combinations and you will get the answer. Another example, if we are looking for the number of two-digit numbers using the digits 3, 4, 5, and 6, when repetition of digits is not allowed, we can multiply the total number of digits, this one, which is the total number of choices for the tens digit, to the total number of digits minus 1, or the total number of choices for the ones digit. Here, we need to subtract 1 from the tens digit because repetition of digits is not allowed. We cannot have the numbers 33, 44, 55, and 66 here because repetition of digits is not allowed. That is why we need to subtract 1 from the total number of digits. So 4 times 3 is 12. Therefore, there are 12 two-digit numbers. Next is the factorial notation. The notation n factorial, where n is greater than 0, and n factorial here is equal to n times n minus 1 times n minus 2 up to 2 times 1. For example, evaluate 3 factorial. To evaluate 3 factorial, you just multiply the natural numbers in decreasing order, starting from 3 because our n here is 3. And so 3 factorial is equal to 3 times 2 times 1, which is equal to 6. That's how simple it is. Just multiply the natural numbers decreasingly, starting from a given n. Let's try solving problems involving factorials and fundamental counting principle. Number 1. Evaluate 5 factorial times 4 factorial. But before I will continue to the next slide, I want you to pause the video for a while and try to solve it in your own. Then compare your answer later. To get the product of 5 factorial and 4 factorial, we need to evaluate each factorials. First is the 5 factorial. Evaluate 5 factorial by, of course, multiplying the natural numbers decreasingly starting from 5 since our n is 5. And so, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Next is the 4 factorial. Evaluate 4 factorial by multiplying 4 times 3 times 2 times 1, which is 24. And after getting the value of each factorials, we are now to multiply 5 factorial and 4 factorial. But please do not literally multiply the 5 and 4. We are here to multiply the values of each factorial. 5 factorials is 120 and 4 factorial is 24. And getting the product of 120 and 24, that is 2880. Therefore, 5 factorial times 4 factorial is equal to 2880. Number 2. How many 4-digit numbers can be formed using the digits 0, 2, 3, 5, 7, and 8 if repetition of digits is not allowed? Again, I want you to pause the video for a while and try to solve it in your own, then compare your answer later. To determine the number of 4-digit numbers that can be formed using the digits 0, 2, 3, 5, 7, and 8, if repetition of digits is not allowed, we need to identify the number of ways we can choose the digits in each place value, starting from the highest. The places are thousands, hundreds, tens, and ones since we are in 4-digit numbers. And the highest there is the thousands place. For the thousands place, there are 5 choices since 0 cannot be used in the thousands place. Otherwise, that's not anymore a 4-digit number. For the hundreds place, there are also 5 choices since 1 digit is already taken in the thousands place, but the number 0 can now be used in the hundreds place. For the tens and ones places, there are 4 and 3 choices respectively. Then apply the fundamental counting principle by multiplying the number of choices. That is 5 times 5 times 4 times 3, which is equal to 300. Therefore, there are 304 digit numbers that can be formed. For the last part, I want you to answer this individual practice. Please comment below your answers and I will check if you are really learning from this video. That's all for today's video. Thank you for watching.